This short clip gives you insight into the use of the bidirectional CAD interface between Ansys Workbench and the CAD system NX 8.5. Therefore, a coiler head of a winding machine will be analyzed. The geometry of the drum is described with the help of several parameters. The design development is driven by two competing goals. On the one hand, the drum weight should be minimized. On the other hand, the dimensional stability with respect to ovality resulting from imbalances has to be maximized. Those aims support resources savings, faster run-up and run-down times, as well as process reliability regarding adherence to close tolerances. Let's begin with the coiler head geometry in NX 8.5. The drum geometry contains renamed parameters. Using an arbitrarily chosen string in their name helps the user to utilize an import filter in case of many available parameters. In the tab Ansys 15, the Transfer button will start transferring the active NX 8.5 geometry into the Ansys Workbench environment. Ansys Workbench provides the framework for different analysis types such as computational fluid dynamics or structural mechanical systems and their organization. Also, a coupling of analysis systems is controlled via the project page. Regarding the properties of the geometry, we check the Smart CAD update and also the comparison of geometrical associativity during a geometry update. This option helps to keep the mesh of already meshed and unchanged parts during the geometry update process. On the project page, one can link easily a structural mechanical analysis with the geometry by dragging the analysis block onto the geometry block. After that, the model setup can be edited. In the simulation environment, we have the graphic window, the structure tree with all relevant data for the model description, and a details window with detailed information about the current selection in the structure tree. In the structural mechanical environment, the transferred parameters are activated. To implement an unbalance, a point mass is assigned to the outer rim of the drum. It should have a mass of 10 grams. Furthermore, the mesh generation is controlled by sizing objects. Next, loads and boundary conditions have to be defined. This is, on the one hand, a frictionless support at the symmetry plane, a cylindrical support and a fixed bearing at the shaft, and a rotational velocity of 10,000 rotations per minute. As a solution object, we insert the total deformation and start then the solving process. The deformation is scaled automatically, displaying the undeformed wireframe and also an animation might help to understand better the deformation behavior of the structure. Entering the parameter set on the project page gives the possibility to change parameter values. After that, the model needs to be refreshed. One can see that the mesh for the unchanged geometry is still present and must not be regenerated. Bearing in mind that we want to reduce the drum weight, we have to activate the mass parameter in the appropriate geometry. Moreover, also the maximum of the total deformation should be an activated parameter. Now, the user can easily define arbitrarily design points. By only one click, all design points will be evaluated. We recognize that one can find an optimal design by hand, but a more sophisticated method, however, would be the use of optimization tools such as design exploration or OptiSlang. To summarize, the bidirectional CAD interface between Ansys Workbench and Annex 8.5 enables us to efficiently control geometry parameters in Ansys Workbench. It allows us to carry out conveniently a design study inside one software environment, inside Ansys Workbench. Now, it's up to you to develop with the help of the bidirectional CAD interface an optimal design.